This short video will explain the concept of reflux and show you how to set up a reflux apparatus. Reflux is simply the process by which a solvent is heated at its boiling temperature for a period of time, but the solvent doesn't boil away because it's returned back into the flask in which it is boiling. So we'll start with a heating mantle. This is just a source of heat. You can also use a plain old Bunsen burner for this if you want. This is the kind that has an attachment on the back so that you can actually attach it to a ring stand and set it up at any height that you might want. We're going to set it pretty much all the way down to the bottom because in this case we won't need to change the height during the process, so we'll just set it down at the bottom of the ring stand. This is just a round bottom flask attached to a device that lets us attach it to the ring stand, and we will eventually lower it down so that it goes directly into the heating mantle, but for now we'll set it up here above. I'm going to just add some water to the flask. You can use other solvents as well, and of course the solvent that you choose will determine what the temperature is of the refluxing material. I'm just going to use water because it's safe and cheap. I'll add some water to the flask. It's also important to add a few boiling chips, boiling stones. These are just inert materials that provide a jagged surface for the boiling to occur, and it doesn't take very many, just 3, 4, 5 chips. Then we will put a condenser on the top. This is a jacketed tube in which water can flow in and out without ever getting into the middle of the tube. That will provide a cold surface for the boiling water to condense on. The water will be going in and out. And I'm going to attach some tubing going to the bottom, which I will then attach to the water source. And the other tube I will attach to the top. That tube then will go into the sink so the water won't spill out all over the table. And I'm going to go ahead and turn the water on in the bottom and out the top. The reason you always want the water to go in the bottom and out the top is so that it constitutes a continuous amount of water. If you have it go in the top and out the bottom, it will just be like a waterfall and won't fill the whole jacket. Now I'm going to lower the container into the heating mantle, and there we go. Notice, this is very important, nothing in the top. You don't put a stopper in the top of the condenser because anytime you're heating a sealed container, you very likely will build up pressure and possibly blow the thing apart. So that's just open to the atmosphere. Do we have to worry about water evaporating out the top? Nope, not as long as there's cold water going through the jacket. At this point, it's going to take a while for that water to heat up, so I'm going to stop the video and then rejoin you here in a minute once the water is boiling and we can see what reflux actually looks like. Welcome back. My reflux is well established now. Notice that the water is boiling nicely. The boiling chips in there are doing their job, and the heating mantle is turned on full. Notice that the top of the column has nothing in it. It's just open to the atmosphere. And as the water is boiling out of the flask into the condenser, it's hitting that cold surface on the inside of the tube and condensing and dripping back down into the container. So this is the process called reflux. We can be guaranteed that the temperature of that boiling material is right around 100 degrees because we know that the solvent is water. If we'd use some other solvent, then the temperature would be maintained at whatever temperature that particular solvent boils at. So thus you can fine-tune it, boil at whatever temperature you might want. Now the question might be, why would you want to boil a solvent at a particular temperature over an indefinite period of time? And the answer is probably because you're doing some sort of a chemical reaction in the solvent, and it requires heating for a period of time at a particular temperature in the condenser. Notice, by the way, that the top part of the condenser has no water boiling in it at all. The water is going through the jacket, as you can see, but on the inside of the tube, the water is pretty efficiently being condensed pretty close to the bottom of the condenser, and thus we can be guaranteed that none of it is escaping out the top.